Today I want to discuss one of the most controversial statements in mathematics, that 0.999 extended to infinity equals 1. Many people don't believe this. In fact, when I first encountered it, it felt wrong to me as well. After all, surely 0.999 extended to infinity must be just a little bit smaller than 1. In this video, I am going to prove that 0.999 extended to infinity equals 1 in 3 different ways. First, we'll use a simple algebraic trick. Second, we'll ask whether there is any number between 0.999 extended to infinity and 1. And third, we'll use the idea of an infinite series. Even after all these proofs, the result may still feel strange. We'll talk about why at the end. So let's begin. The first method is the algebraic proof. Now let x is equal to 0.999 all the way to infinity, and let this be our first equation. Now we multiply both sides by 10. And we get a second equation, 10x is equal to 9.999 all the way to infinity. So this is our second equation. Notice something interesting? The decimal part on right hand side is again 0.999 extended to infinity. Now let us subtract these two equations. We get 9x is equal to 9, and this means x is equal to 1. But we defined x as 0.999 till infinity. Therefore, 0.999 with infinite nines after the decimal equals 1. This proof is short and elegant, but some people don't like it because it feels like a trick. So let's try a different approach. In this approach, we ask if there is a number between 0.999 and infinite nines and 1. So if 0.999 extended to infinity and 1 are different numbers, then there must be some positive distance between them. Let's look at some examples. So we know that 1 minus 0.9 is equal to 0.1. 1 minus 0.99 equals 0.01. 1 minus 0.999 equals 0.001. 1 minus 0.9999 equals 0.0001. Every time we add another 9, the gap gets 10 times smaller. Now ask yourself, what is 1 minus 0.999 extended to infinity? How many zeros should appear after the decimal point? The answer is that there is no positive gap left, because this will equal to 0.000 up to infinity, which is essentially 0. And so once again, 0.999 extended to infinity equals 1. Now we move on to the third method. We use the concept of an infinite series. So the third method is the infinite series method. Let us write 0.999 extended to infinity in a different way. This can be written as 9 by 10 plus 9 by 100 plus 9 by 1000 and so on up to infinity. Now factor out the 9. We get 9, 1 by 10 plus 1 by 100 plus 1 by 1000 up to infinity. And let's say this is x. And so this becomes x here. Now let us call this series inside the bracket, this part, let us call it S. So this is the series we have. We have 1 by 10 plus 1 by 100 plus 1 by 1000, and it is extended to infinity. This is a geometric progression. So let me use another color here. And so a geometric progression is a series of terms which go something like a times r, a times r square, a times r cube, and so on. A is the first term of the series. And r is the ratio between the consecutive terms. And this is an infinite geometric progression. The sum of an infinite geometric progression is given by, wait for it, a divided by 1 minus r. In our case, for this equation, 1 by 10 plus 1 by 100 plus 1 by 1000 extended to infinity, a is equal to 1 by 10, which is the first term. The ratio between the terms is again 1 by 10. So the sum of this infinite GP, S, will be equal to A, which was 1 by 10, and divided by 1 minus R. R is again 1 by 10. So this becomes 1 by 10 divided by 9 by 10. This gives us 1 upon 9. Now remember, initially we started with trying to find out the value of x, and x is equal to 9 times s. So x is equal to 9 times s. So this becomes 9 times 1 by 9, which equals 1. So despite using 3 different ways to explain it, why does it still feel weird? Because x is equal to 1, that means 0.999 extended to infinity equals 1. And this is what we set out to prove, but it still feels weird. Many people are still uncomfortable with the conclusion. Why? I think the reason is that every finite decimal is less than 1. For example, 0.9 is less than 1, 0.99 is less than 1, 0.999 is less than 1, and 0.9999 is less than 1. Every finite decimal is less than 1. But 0.999 extended to infinity is not a finite decimal. It is not a finite decimal. The dot means that the process never ends, and infinity behaves different from our intuition. The difficult part is understanding what we mean by an infinite process. Mathematics tells us that as we keep adding more and more nines after the decimal point, the number gets closer to 1. In fact, it gets so close that there is no gap left. And that's why mathematicians write 0.999 extended to infinity equal 1. Thank you for watching. If one of these proofs convinced you, let me know which one was your favorite.